All right, so we just finished up talking about how to calculate the average velocity between times 2 minutes and 8 minutes. And now we're going to figure out what the average acceleration is, because that's part B of the problem. So the average acceleration is the change in the velocity over time, right? The change in velocity with respect to time. And for the same kind of the situation that we had below with the position, we need to look at our velocity graph because we're just going to figure out what the slope of this line is here on the velocity versus time graph. All right? So how do we do that? Well, we know that the velocity at time 8 minutes is equal to 2.2 meters per second. That's our final velocity minus the initial velocity, which was 0 meters per second, and I'm going to keep the units in there, divided by the time. And the time here is 6 minutes, right? 8 minus 2 minutes is 6 minutes, and converted into seconds is going to be 360 seconds. I'm not showing you my work. I'm sorry. 2.2 meters per second minus 0 meters per second, its initial velocity at 2 minutes, or the velocity at the 2 minute time mark, and then the change in time between the two intervals that we're interested in, which is 360 seconds. Right, so we can figure out what the average acceleration is. If you look, these are just going to, this is the number minus the number. The units here don't disappear just because you're subtracting. So this, the numerator is 2.2 meters per second divided by 360 seconds. So we have meters per second divided by seconds. So in terms of units, we know that we're going to get meters per second squared, which is the units for acceleration. So we know that we have a nice check on our units, and that worked out really nicely. And then we could grab our calculator and take 2.2 divided by 360, because I can't do that in my head. So whatever we would plug that in, we would know that if you look, this is 2.2, we're going to be dividing something by more. This is definitely going to be less than 1, right? There isn't going to be anything left here. 360 seconds doesn't go into 2.2 even one time. It goes in like 0.1 or something like that, 0.7-ish, something like that. And so we can figure that out, and that's what our average acceleration is going to be for that interval. And let me go back to the question to see if there's anything else we can sort out. Oh, it says what are the average velocity and the average acceleration in the time interval of 3 minutes to 9 minutes. So you could do the exact same thing. I find it kind of odd in this question that they're asking you to sketch the position versus time and velocity versus time curve at the end. You could certainly solve this problem without sketching those graphs, but it really is helpful to give you a sense of what numbers are we looking for and how does this relate graphically, right? I want you to use graphs and I want you to use pictures as tools to help you with your numerical calculations, not vice versa. So I don't want you to like sketch things out or solve things simply with the mathematics and then try to make pictures at the end. I mean, you could do that, but you're kind of shortchanging yourself. It's a very useful tool to use pictures and graphs to kind of help you make sense of problems, because otherwise you're forced to keep a lot of numbers in your head and try to make a lot of connections, which they're perfectly fine. It's just kind of it's not necessary to understanding physics and understanding how to do these types of problems. So in summary, draw some sketches, make sure you keep your units in the problem. They can be very useful for checking, and I hope this was helpful.